Oh. Oh, hold on. Shoot. There we go. What does that mean? There we go. All right, we're ready? Pick this stuff up. What are we doing today? We're doing 8-3 on 8-3. Yes, no, maybe? Hello? Maybe not. Hello? Can you hear me? Maybe I can't hear you.
Yes, ma'am. I'm just not sure.
Okay. It's not sharing?
No, I'm saying I'm just not sure where we're at.
Oh, okay. No, I haven't done anything yet. I'm just making sure we're on section 8-3 and just making sure everybody can see my screen and everybody can hear me. We're good? Okay, so A3 is, okay, perfect. A3 is polar form of complex numbers and de Moivre's theorem. So we've been working with polar form this last week, where it's R cosine theta plus I sine theta. This right here, let's call it Z, is, sorry, this is polar form of a number. Okay, we did it with vectors. I'm getting this from page 101, when we were doing it with vectors. On page 101, it was V equals the magnitude, which we're going to call R now, of cosine theta I plus sine theta j, right? This is when we were talking about vectors. Well, today we're going to talk about complex numbers, okay? Complex numbers is just a fancy way of saying imaginary numbers. And we all got introduced to imaginary numbers in college algebra. And they are A plus BI, right? Every imaginary number could have a real component. That's a real number. And then if this, of course, is an imaginary number. Are we okay? Do y'all remember imaginary numbers? So a complex, go ahead. We didn't? On which page? I'm probably on the wrong page. So I swear we did that. 109 is just, we just graphed it and you had to test symmetry. And I was like, that's basically the same thing. So I may not have done it. Yeah. And then on 110, I specifically remember pulling a Desmos and showing you how to graph those. And it was like a meteor. See, Georgia said we did all of them. Okay. So we're on page 111. All right. So if you look at the top part, it says recall. We're saying recall because you did imaginary numbers in college algebra. Section 3-4, college algebra, you did imaginary numbers. A complex number is a form of A plus BI where A and B are real numbers, okay? And I is an imaginary value. I should make this more over here. Ooh. So A and B are real numbers and I is an imaginary value, which we call complex. A complex number can be plotted on a complex plane. So I really want you to think about it. So far, listen to this. We've had the rectangular plane, which is the one that you've been working with since elementary school, right? We've had a vector plane where you had the y-axis and the j-axis. You have had a polar plane, that round one, remember? Where you had r comma theta. This was your polar plane. And now I'm talking about an imaginary plane where you're going to have a real axis and an imaginary axis. So you worked with imaginary numbers back in college algebra when you had to find zeros of polynomials. But sometimes you're like, oh, you're looking for 4 zeros, but you couldn't see 4 zeros when you graphed it. You only saw like 2. And it's because the other 2 zeros were imaginary. They were graphed on the imaginary plane. But in college algebra, we say, oh, don't worry about it. You're just not going to see it because we're not really going to actually graph the imaginary plane. But now that you're in pre-cal, you are. Okay, so you're going to graph the imaginary plane. And so those are this is the only one you worked with before this class. And this is why pre-cal is a little bit more difficult. Remember I said pre-cal is a huge jump because you're working with a lot of different planes than just the X and Y axis. But the cool thing about it though is graphing them is exactly the same. So for example, if I wanted to graph 3 minus 4i, this is one number, it's an imaginary number. So it's only going to represent one dot. Remember, this is the real plane, this is the imaginary one. So you would go 1, 2, 3 on the real axis, down 4 on the imaginary axis, and that would be your dot. So this right here is 3 minus 4i. Is that okay? Right under that, you should have some, You have a question? Sure. This is not really in the notes. This was just me lecturing, but I understand if you want to write it down. But just in case you thought it was in the notes, it's not in the notes. Maybe I should add it, but you don't see this part on the notes. Okay, so the next thing that we're going to talk about is conjugates. Okay, so at the very bottom of page 111, again, I don't have it in here. I should probably add it. But do y'all remember what a conjugate of an imaginary number is? So if you have A plus BI, no. No, a conjugate, are you just talking about I? We could talk about that later. But a conjugate of A plus BI is A minus BI. Does that make sense? So if this right here is 3 minus 4i, then what would the conjugate be?
3.
Yeah, 3 plus 4i. So if I wanted you to graph that, 3 plus 1, 2, 3, 4, 3 plus 4i would be here. Okay, so this is me graphing its number and then the conjugate as well. Okay, so then I have 2 more for you. I have B, which is negative 2 minus 3i, and I have C, which is negative 4 plus I. I want you to graph this number, but I also want you to graph its conjugate. We okay? So I'll give you another minute. X-axis. Yes. All right, so here we go. So we would have -2 minus 3i. So you should have your first dot here. We agree with that? And then its conjugate would be -2 plus 3i. So you should have this picture, the number and its conjugate, right? -4 I -4. Is everybody okay with this? Example, real quick. What if I had 6i plus 2? What would the conjugate be? No, I tricked you. Yes. It would be -6i plus 2. So when you're doing a conjugate, the only thing that changes signs is the I value itself, the imaginary value. The real part of it stays the same. So be careful because I could switch where the I is. It's not the number in the middle that changes, it's the number in front of the I component that changes. Does that make sense? So just be careful on that. Any questions on plotting imaginary numbers? We're okay? Okay, the next thing that we're going to talk about is being able to find the absolute value of imaginary numbers. You know how to find the absolute value of real ones. What's the absolute value of -6? 6, because absolute value changes everything to be positive. So now we're going to learn how to take the absolute value of imaginary numbers. Okay, so to take the absolute value of an imaginary number, it is literally just the square root of a squared plus b squared, which should not come as a shocker because you've used this formula many, many times. So if you want to take an absolute value of an imaginary number, then all you're doing really is finding the length of it. If it was a vector, we call it the modulus of it. Okay, and that's all you do. So for example, let's say that I wanted to, I had an example of 7 minus 3i. This is an imaginary number. It is one imaginary number. And I told you I wanted you to find the absolute value of it. So what is the absolute value of 7 minus 3i? What is the absolute value of, what is the modulus of this number? Modulus and absolute value, same thing. So then you would just take the square root of 7 squared plus -3 squared. That gives you the square root of 49 plus 9. The square root of 58. Does that come out clean? No. I'm trying to think if you can simplify this. No? I'm sorry? Because what you're doing is you're squaring everything on the inside, just making it positive. Because remember, imaginary values, like, here's a side note in case you forgot. I is equal to the square root of -1. I squared is equal to -1. I cubed is equal to, no, I don't care about I cubed. I to the 4th is equal to 1. So by you squaring it, you're taking it out of the imaginary plane. Does that make sense? Because you're trying to make this a positive value. So you're taking it out of the imaginary plane, and all you're doing is finding its length. Ooh. Yes. just in case I forgot. So you're taking it out of this like imaginary plane and actually just finding the length from the origin. Okay. All right. So you do B for me. B says negative square root of 2 plus I, the square root of 2 over 2. And I want you to find the modulus of this. Anybody find it? No, you don't put the I underneath. Yeah, I think it's just 1. So you did the square root of negative square root of 2 over 2 squared plus the square root of 2 over 2 squared, which equals 2 over 4 plus 2 over 4. We okay? Is everybody okay with how to find the absolute value of an imaginary number? So this is kind of what I'm doing today. I'm going to start with a real value, which you should know how to do, and then talk about how you do the same operation, but with an imaginary number. Is that okay? Okay, moving on. The next thing that we're going to do is we're going to talk about how you add and multiply imaginary numbers. So let's talk about real numbers first. We know that 3 plus the square root of 4, okay, plus 4 plus 5 the square root of 4 equals what? If I told you to add these together, what would the answer be? Anybody? Y'all go quiet and I don't know if can y'all hear me? Hello? You can hear me? Okay. I don't know what's going on. Y'all, I don't know if I can't hear y'all. It would be, okay, maybe that's why. It's 7 plus 6 the square root of 4. I'm not stopping to teach real stuff, okay? We should know how to add these numbers together. We're just adding. 3 plus 4 is 7. And if this is 1 the square root of 4 and 5 the square root of 4, if you have 1 Skittle plus 5 Skittles, that's 6 Skittles. So if you 1 square root of 4 plus 5 square root of 4 is 6 square root of 4. That sounded bad. Was it? That sounded far. I don't know. I think there's something wrong with my speakers. Okay. So anyway, so now what we're going to do is we're going to do the same thing, except we're doing it with imaginary numbers. So for example, if I had negative 1 plus I, that's an imaginary number, plus 2 minus 3i, all you do is add their corresponding positions. So z1 plus z2 would equal 1 minus 2i. So if you look at your notes, they called the first one z1, the first complex number, and then the second complex number, they call that z2. And so when you're adding imaginary numbers, all you have to do is add the corresponding positions. Okay. So I added the -1 and the 2 together, and I added the positive I and the -3i together. Just like up here, you added the 3 and the 4 together, and you added the 1 square root of 4 and 5 square root of 4 together. Is that okay? So you just add them together. All right, here we go. I'm afraid to ask. In the real plane, what if I wanted to do 3 plus the square root of 4 times 4 plus 5, the square root of 4? What if I wanted to multiply these numbers together? You would FOIL this, right? So you would get 12 plus, outer would be what? First outer would be 15 square root of 4. Inner would be 4 the square root of 4. And last would be 20. So then you would get 32 plus 19 the square root of 4. And that would be the answer if you were doing real numbers. So I literally just FOILed it. Is that okay? So that's real, but today we're practicing doing the same thing, except we're doing it with imaginary numbers. So if you look at the problem, it wants me to do z1 times z2. So we're going to do -1 plus I times 2 minus 3i. So keeping up there what we did with the real numbers, I want you to do the same thing with the imaginary ones and tell me what you would get. Or type it in the chat if I'm not hearing your thing correctly. We okay? Did we FOIL? When you FOIL, what do you get? -2 plus 3i plus 2i minus 3i squared. We hear that? Okay, and then it told me to graph them, so I graphed them. Please ask me a question. Is everybody okay? Where'd this come from? How come that's that? Where's this coming from? Everybody okay? Moving on? Okay, good. Yes. The 1 minus 2i? No, it didn't say to. Me just reading the instructions. I don't think I was supposed to. I don't even think we're supposed to graph the word. It just says find and sketch z1 plus z2 and then z1 times z2. That's it. So just 2 points. Okay, moving on. Okay, so what we've done so far is I showed you how to add two complex numbers and how to multiply two complex numbers together. The next thing that we're going to do is we are going to change complex numbers into polar numbers. And the reason that you want to do this, be able to do this, is because sometimes what's going to happen, and maybe I'll do one here in a little bit. Let me see if there's one that's like not so bad. Like not horrible. I don't know. But is if I were to tell you to do something like -1 plus I, don't write this down. I'm just telling you to do something. How did you do -1 plus I to the 5th power? Then that means you would have to write -1 plus I times -1 plus I times -1 plus I like 5 times. And then you would have to FOIL it all out and simplify and make sure that you don't make a mistake. Does that make sense? What if I change this 5 to 15 times? So nobody wants to do that. That's too long. But it's easier to do something like this if you're in polar form. I can actually do this in polar form in like 1 step. Okay, so instead of doing these 15 steps. So the first thing before we get to that, the first thing that you have to learn how to do is change a complex number into polar form. Okay, so like I said in the beginning of class, polar form is z equals r, open parentheses, cosine theta plus I times sine theta, where this is your real part and this is the imaginary part. Okay, and remember when we're dealing with polar form, you're talking in terms of r's and thetas. Now, we've already know how to find r and theta. We learned that before when we were doing polar. To find r, all you have to do is find the modulus of your imaginary number. So that is the square root of a squared plus b squared. So that's how you find r. Same thing. And then we also know how to find theta because tangent of theta is equal to b over a. It's equal to y over x, but you have to remember what quadrant you're in. You have to remember what quadrant you're in. We've already done this, okay? So let's just practice that, okay? Let's just practice writing imaginary numbers into polar form, okay? All right, here we go. So the first example, nice and slow, is -2 minus 2i. So this is an imaginary number, but we're going to change it to polar form. So the first thing that we're going to do is we're going to find r. Now remember, r is the absolute value of your complex number, which we learned how to do. So this will be, what is that, 4 plus 4? No, absolute value represents modulus. Z is what it's like the default of what they call all of imaginary numbers. So this imaginary number, we're going to call it Z. So that gives me what? 2 to the square root of 2? like when they name vectors, they usually use U and V. If you did the vector homework, you got a lot of U's and V's because that's like the default of naming vectors. Well, the default for naming complex numbers is using the letter Z. Number 2, we're going to find the angle. So we know that tangent of theta has to equal -2 over -2. So tangent of theta has to equal 1, right? So where does tangent inverse equal 1? Think about what you say before you say it. What is theta? Anybody? Nope. What's theta? Is it a Monday? Is that why this is super quiet today? Exactly. I agree with everything you just said. So then what's the answer? No. Mm-mm. Yep. Anybody? Yes, it's 5 pi over 4. Is that okay? 5 pi over 4. We're in quadrant 3. -2, -2i. That's why we plotted stuff before. -2, -2i. You're in quadrant 3. So you can't be pi fourths because that's the wrong quadrant. Is that cool? So then that means your final step is to write z in polar form. So that would be 2, the square root of 2, open parentheses, cosine of 5 pi over 4 plus I sine of 5 pi over 4. This and this are the same number. They're exactly the same number, except the top one's on the imaginary plane and this one's on the polar plane, but they are exactly the same number. Is that cool? So you try B. The next example just has -5i. Now this makes me itch a little bit. If you need to, you can come over here and say 0 minus 5i. It just means the imaginary value, the real value is 0. That's all it means. So 0 minus 5i. So go find step 1. Find your R value. Yes. Yes, that's the answer. You sure? You can graph it. No, it won't accept it. You have to type this in. But what do you mean by graph it so that you could see it? Like you graph it like this to graph it? But if it's asking you, I was gonna say if it's asking you to put it in polar form, you have to type this in. Right. I don't even know how to graph this in a calculator. Mm-hmm. I mean, I guess you could do 2 square root of 2 comma. Yeah, I don't know how to even graph this in a calculator. Okay, so here we go. Next one. Anybody come up with R? Yep. Okay, R is 5. I'm cool with that. And then now we're going to find tangent of theta is equal to B, which is negative 5 over 0. Uh-oh. Isn't that, where is tangent of theta undefined? Because there's no 1. There's no real, it's not 1 minus 5i, it's 0 minus 5i. There's no real component. Where is tangent undefined? Where's tangent undefined? Tangent is undefined at pi halves and at 3 pi over 2, but it's not pi over 2 because if you were to graph 0, negative 5, 0, negative 5 would be down here, which is 3 pi over 2, not pi halves. So 3 pi over 2 would be your answer. And so then 3 is to write this in polar form, and you would get 5, open parentheses, cosine of 3 pi over 2 plus I sine of 3 pi over 2. And that is your answer. We okay? Example. What if we had 3 minus 3, the square root of 3i? And I wanted you to write this in polar form. Number 1. Change this to, we'll find r by finding the modulus of z. That'll give you 9, right? Plus 27? We okay with that? I guess I just need some chime in on like where we're getting confused. Are we okay with finding R? Maybe I should pause before. I want you to do it before me, not after me. That makes sense. So I'm pausing before and do theta. Find theta. Anybody find theta? No. Neither of those sound like angles. Good job, Garrett. 5 pi over 3. Sounds good. Okay. So number 2 should be tangent of theta equals B over A. So -3, the square root of 3 over a, which is 3. The 3's would cancel. You would get negative the square root of 3 as your point. I don't want to know the point though. I want to know the angle. So where does tangent equal negative square root of 3? So you go to your unit circle, you look for where tangent is equal to negative square root of 3, and then you get theta equals 5 pi over 3. And now that you have that, you get z equals 6, open parentheses, cosine theta plus I sine of theta. And this would be your answer. Is that okay? So while y'all writing that down, I'm going to look at the next rule, okay? So if you look at the rule that's under the bottom of page 113, it's showing you how to multiply and how to divide complex numbers, okay? So you don't have to write this down. I'm literally writing down what you should see at the bottom of page 113. So if you have one complex number and it has, of course, your R value, and it has cosine theta 1, plus I sine of theta 1. And then you have another complex number, R2, cosine of theta 2 plus I sine of theta 2. So you have two complex numbers. Just like over here, I don't know where I did it. Maybe up here. Okay, like up here, we had two complex numbers. We had -1 plus I, that was one complex number. And then we had -2 minus 3i, that's another complex number. And then we did multiplication or we added them, whatever the case may be, right? So here we have two complex numbers. They're just in polar form. And if you look at the operations, if you wanted to multiply z1 times z2, you wanted to multiply the complex numbers together, all you have to do is multiply the R values together, and then you're going to add the angles. Remember, multiplication becomes addition kind of thing? So you're just going to add the angles together, and then that'll be it. That'll be the same thing as us just adding the corresponding positions if we were in imaginary form. So if we're in polar form, all you have to do is multiply the R values and then add the angles together. If you were dividing z1 by z2, okay, we're dividing them because we didn't do that earlier. We did not divide imaginary numbers earlier in complex form. Let me tell you right now, it's a hot mess. I'll show you, but it's a hot mess. It's so much easier to divide in polar form. So in polar form, all you would do is divide the R values and division becomes subtraction. You would just subtract the angles, and that's it. Does that make sense? I mean, I'm just giving you the formula. That's all we have to do. We okay? Everybody see this at the bottom of page 113? Okay, so now we're going to apply this on the next example. So it says Z1. Here's the first example. Here's one complex number in polar form. It's the square root of 3, open parentheses, cosine of 5 pi over 4 plus I sine of 5 pi over 4. So that's 1. And then Z2 is 2 cosine of pi plus I sine of pi. Is everybody okay with that? Everybody see where I am? All right. Okay, and so then if you look at the instructions, it says find the product and the quotient. And then it says express your answer in polar form. So our final answer, it just wants us to leave it in polar form. Okay, so I'm gonna explain a couple of things on this one example. So the first thing that we're gonna do is we're gonna do Z1 times Z2. So I'm gonna multiply these two numbers together. If you do that, you have to multiply the R values together. Is that okay? So we're multiplying the 2 and the square root of 3 together. And then open up parentheses. And this would become cosine of 5 pi over 4 plus pi plus I sine of 5 pi over 4 plus pi. All I'm doing is multiplying the R values and then adding the angles together. Correct. And so then this becomes 2 the square root of 3 cosine of 9 pi over 4 plus I sine of 9 pi over 4. Now, this is an allowable answer to me. I would take this, 2 the square root of 3 cosine of 9 pi over 4 plus I sine of 9 pi over 4. This is absolutely fine. I would totally take this. In WebAssign, it might constrict your angle. I don't know if it does or if it doesn't. I haven't done your homework. I don't do your homework. But it doesn't constrict your angle. If it does constrict your angle, well, then you have to fix it. So for example, in WebAssign, if it says, oh, but your angle has to be between 0 and 2 pi, well, then I have to fix this because 9 pi over 4 is over 2 pi. Does that make sense? So then I would have to fix my angle, and this would become 2 the square root of 3 cosine of what? Pi over 4? Okay, so this is an acceptable answer in complex form. The problem is that if it tells you that your angle has to be between 0 and 2 pi, well, then you're going to have to fix it. So this is my same answer in complex form, except I fixed the angle. Make sense? So this is what I would put in. Ugh, nobody stopped me. I made a mistake. This is polar form. Is this okay? Any questions? Oh my God. Okay, now let's say this is your answer in polar form, but let's say that it said, nope, I want you to change it to complex form. That means it wants us to put it back to being imaginary. Okay, so then you would just convert this. This would be 2 the square root of 3, and this would be the square root of 2 over 2 plus I the square root of 2 over 2. And then you would distribute. So what would you get? Square root of 6 plus I the square root of 6. And this is your answer in imaginary form. So this is the same number. They're the same number, except this one's in polar form and this one's in imaginary form. I'm stopping. What happened? Ooh, I have a question. Hold on. What happened to the nines? What happened to the nines? The nines? This nine? These nines? I fixed it. 4 goes into 9 2 times and 1/4 left over. If you want your angle to be between 0 and 2 pi, you went over 2 pi. So then how did you travel? 2 pi and 1/4. So that's 1/4 of a pi. You have to remember, you change it. Tell me how many times you went around the circle and end up where you are. Does it make sense? 9 pi over 4 is over 2 pi. And if you have to stay, the homework says that you have to stay in between 0 and 2 pi, then you're going to take a 2 pi out of it. You're going to take the 2 pi out, and that leaves you with the pi fourths. It's okay. We okay with that? Okay, moving on. What if I want to divide? So what if I want to divide z1 by z2? This one's not going to be that bad. So if you want to divide z1 by z2, then all you have to do is divide the r values. So you would have the square root of 3 over 2, and then you would subtract the angles. So if you subtract the angles, you get 5 pi over 4 minus pi. Do you agree with that? 5 pi over 4 minus pi plus I sine of 5 pi over 4 minus pi. And so then if I were to simplify this, and that's it. You don't have to fix the angle because the angle is already in between 0 and 2 pi. So you don't have to fix it. And all you did was divide the r values, and then you subtracted the angles because you're dividing. And then if it wanted you to put it in imaginary form, you would just convert the cosine pi over 4 and sine pi over 4 into square root of 2 over 2, and then distribute your r, and that would be your answer. Is that okay? If you're okay, if you're up to here, go ahead and try B. Yeah. If you're okay with this one, try B. I'll stop after B. No, I won't. We'll do C. We'll try to do C. We'll stop after B. We'll start C. Are we okay with this one? Yes. Okay, so the next one's with angles, so hopefully that's a lot easier, right? So you get z1 times z2 would equal, what is that, 6?
Yes, ma'am.
Cosine of 135? Done. 135 is in between 0 and 360. I mean, if it restricts it usually restricts it to one rotation around the circle. So 135 is fine. And that's even if it restricts it at all. Sometimes it doesn't restrict it. Am I wrong? 75? I know, but we're adding 75 plus 60. Okay. And then Z1 over Z2 would equal what? 1/3 cosine of 15? Is that okay? Any questions on this one, on B? Oh yeah, I'm not moving. But I think I'm going to stop there for today. On C, before we do C for tomorrow, I would try myself to put this into polar form, because as you can see, they were given to you in imaginary form. So I would put both of those numbers into polar form, because that's something that we practiced today, and then see if you can multiply and divide them after you get them into polar form. So that's definitely something that I would practice, so that when I'm doing it, you won't have so much to write, because it is a pretty long problem, because you have to change it into polar form first and then perform the operation of multiplication and division. And tomorrow I'll show you with C, remind me, because I know I'll forget. I'll show you with C why we do this, because some of y'all might be thinking, but I know how to multiply these just by foiling it. And that's true. But I'm going to show you why this is way easier to change it into polar and work in polar versus leaving it in imaginary and complex. Okay? So remind me to show you how it's the same and why you want to do it this way. Okay? So we'll stop there for today. I will see y'all tomorrow. Hopefully we drink more coffee. Y'all have a good one.
Thank you.